Dear colleagues, I'm glad to present you a report on the topic method and computer tool for Synphase prediction of computer network traffic load level. The authors are Mykola Khvostivsky, Lilia Khvostivska, and Irina Dedi. One of the key parameters of a computer network is traffic, which plays an important role in the process of assessing user activity, monitoring network operation, as well as analyzing its functioning. Predicting network traffic load levels in time space is one of the methods of avoid congestion, which allows to increase the efficiency of a network resource use and optimize its performance. For this purpose, various mathematical models and computational methods are used. Among the most well-known traffic models, one can distinguish the Poisson distribution, Markov processes, recovery processes, and phase recovery processes on of IPP models. Modulated Markov field model, autoregressive models, stationary processes, fractal Brownian motion, and periodically correlated stochastic process. Based on the models, various computational methods and computer tools have been created for analyzing traffic data in order to predict its load. However, all of these models, with the exception of the periodically correlated stochastic process, do not take into account the relationship between traffic values in different daily periods, which allows tracking the dynamics of traffic change in time space. This is especially important for network load for nesting tasks. A graphical representation of computer network traffic registered for 7 days within the park complex residential complex is presented in figure 1. The model of network traffic load data behavior presented as a periodic variability and also provides the use of methods and algorithms to study their relationship using the following expression 1. The network traffic data model expression 1 provides extensive processing and analysis capable, including Synphase filtering and component processing to obtain quantitative and informative indicators. These indicators reflect the level of motion correlation of the amplitude time characteristic of traffic at different times of the day. Studying the level of stochasticity of mutual correlation between network traffic data indicators at different times of the day allows for load forecasting determined in advance the optimal operating models of the network equipment. This helps ensures the stable and high quality provision of communication and information service to network users. Synphase processing of network traffic data is based on the assumption that informative traffic features can be represented as functions with recurring time-dependent characteristic in the form of Synphase components. Expression 2. Synphase components allow us to isolate characteristic features of network traffic data, which helps to increase the accuracy of predicting its load in the general context. The sequence of in-phase processing of computer network traffic is presented in Figure 5. Figure 3 presents an algorithm of synphase processing of computer network traffic data. The implemented algorithm Figure 3 allows to programmatically create a computer system for synphase processing of network traffic focused on calculating synphase components which act as indicators for effective prediction of computer network traffic load. The guide utility as a component of the MATLAB environment made it possible to programmatically implement a computer system with a graphical interface for predicting computer network traffic. Figure 4. An enlarged fragment of the result of processing computer network traffic data is shown in Figure 5. An enlarged fragment of the average Synphase 3D components is shown in Figure 6. It was found that in the period from 3 a.m. to 5 a.m. and from 5 p.m. to 10 p.m., an increase in the traffic load by customers is observed. At this time, providers should activity the operation of most of the network equipment to avoid overload modes on their functions link. At other times, providers should transfer a significant part of the network equipment to the economical consumption mode in order to save electricity and increase the resource of equipment operation. In order to verify the correctness of the decision made, test the data of unchanged traffic was created with 7 days. The results of its synphase processing were obtained using the implemented program, Figure 7. Based on the processing of stable traffic data, Figure 7, it was ascertained that the in-phase components are at zero level both in the 3D representation and in their averaged form. Therefore, the developed computer system correctly displays on its output the results that correlated with the input. In conclusions, the calculated synphase components of computer network traffic data submit via the periodical correlated stochastic process numerically reflects the future behavior of network load by customers, thereby providing a clear solution to the problem of predicting network traffic load in order to optimize the function of network equipment based on the power of Synphase component. Thank you for your attention.